We are going to take a look at a few problems from the Math 3 Unit 3 Worksheet 2. And I'm going to start with number 2. Part A, we're asked to find the degree and leading coefficient of f of x. And in doing so, this is not in standard form, and so we want to focus in on the, for each factor, if we were to multiply this together, the three parts with the x. If we were to multiply x squared times x squared times x squared, we would end up with x to the 4th power. And it would be positive 1. There would be a positive 1 in front of that. And that's your leading term. And so our degree is 4. And our leading coefficient is positive 1. So because our degree is even and our leading coefficient is positive, we could say the right end points up and the left end points up as well. We're not sure what happens in the middle, and so we can write that out. The right end goes up to infinity, and so does the left side. Next, we want to find x-intercepts and their multiplicity. Multiplicity is how many times you repeat an x value. And so in order to do this, we want it in factored form and split this up. I'm going to rewrite f of x as x times x. So instead of writing x squared, I'm going to write x times x plus 2 times x minus 7. So we see f of x has 4 factors with a variable, and these are linear factors, and each factor is going to give an x-intercept. If you have repeat factors, you're going to get the same x-intercept more than once, and so that's what we introduce the idea of multiplicity. So to find an x-intercept, you set your factors equal to 0. And you set f of x equal to 0. And so we get x equals 0, x equals 0, x plus 2 equals 0, and x minus 7 equals 0. So it gives us 2x equals 0, it gives us an x equals negative 2, and it gives us an x equals 7. So our x-intercepts are 0 with multiplicity of 2, which means we have 2 zeros. That's just a fancy way of saying we have got 2 zeros. We got a negative 2 with a multiplicity of 1, because there's only one of them. And we have 7, and there's only one 7, so we say that has a multiplicity of 1. To find our y-intercept, we plug in 0 for x. So we evaluate f at 0. And we get 0 squared times 0 plus 2 times 0 minus 7, which is 0 times 2 times negative 7, which is 0. So our y-intercept is 0. How many distinct x-intercepts? We found our x-intercepts, 0, 0, 2, negative 2, and 7. So we have 3 distinct x-intercepts. How many zeros are there? A 0 is a value that you plug into your equation to get a value of 0, and in this case we have 3 distinct zeros. Which are the X-Intercepts. X-intercepts are always zeros of a function. If you plug the 7, the -2, or the 0 into that function, you'll get an answer of 0. Next, let's look at number 8. So the instructions here are to sketch the graph of the polynomial function and to label all x and y-intercepts. So it's there's a few things we want to do here. We want to find our x-intercepts. Those are important for graphing. So I'll go after that first. Because this is factored, we set h of x equal to 0 and solve, and so we end up taking each factor and setting it equal to 0. So the first one, if x plus 2 is 0, we get x is -2. Here we have two of them. We have two x minus 3's. And so if we set them both equal to 0, we get x equals 3 twice. And we have one x minus 1, which gives us x equals 1. So for x-intercepts, we have one at -2. We have 2 at 3. So I'm going to indicate the multiplicity is 2. And then we have an x-intercept at 1. So I'm going to put a point at each of those spots. So one at -2 on the x-axis, one at 3, and one at 1. And if the multiplicity is odd, when we draw our graph, it's going to pass through that x-intercept. If the multiplicity is even, which it is at 3, then when we hit that x-intercept, it's going to bounce back. And I'll point that out when we get there. So we found our x-intercepts. Let's find our y-intercept. We could plug in 0 for x, and we get -0 plus 2 times 0 minus 3 squared times 0 minus 1, which is -2 times -3 squared times -1, which is -2 times +9 times -1, which is +18. So I'm going on the y-axis, I'm going to put a point, and I'm going to label that at 18, height 18. Lastly, we need to know the end behavior of our function. So in order to find the end behavior, we need to know the leading coefficient and the degree. So our degree comes from multiplying, well, to get both of them, here's what I'm going to do. I'm going to rewrite this as negative x plus 2 times x minus 3 times x minus 3 times x minus 1. And the pieces we need to multiply together are the negative, the x, 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 and x. So the highest degree of each factor here. And we end up with negative x to the 4th power. So our degree is going to be 4, and our leading coefficient is going to be -1. Our degree is even, our leading coefficient is negative, and so that tells us that the right end of our graph points down, and so does the left, because the leading coefficient being negative makes the right end point down. Because the degree is even, both ends point down. So in my graph, right end points down, left end points down. And remember, when we hit the 3, we're going to bounce here. So I'm going to go from left to right. From pointing downward, I'm going to move up to my first x-intercept. If there's only one, you pass through. Multiplicity of 1, you pass through. You hit that y-intercept. You get to the next intercept. There's only one of those, so you pass through. Go back to the next x-intercept. There's 2 of them, so you bounce. When you hit it, bounce back. And you should be headed in the direction of your arrow. We can't pass the x-axis anymore because that would give us another x-intercept, but we found all our x-intercepts, so that's our graph. That's what we want. And we'll stop at that part.